Hi everyone, this is Olivia, and today I want to record a quick video on how to run Kani for the Verify Rust SCD challenge. So there is a written tutorial on the challenge runbook here that goes through step by step. Feel free to check it out, and let's dive in. So this is under the assumption that we have already cloned the Verify Rust SCD repo. And so here, as an example, so each challenge usually asks to verify functions in a specific module. So let's take the non-null module, for example. Now this is the actual file that contains all the functions and APIs. So the convention here is to keep the harnesses in the same file. An example here is that we will start this verify module at the bottom of it with the appropriate annotations, and all the harnesses is going to go in here. So we have a simple example here. So what we'll do is we'll say that this is approved for contract, and then we'll also tell it the specific functions we're verifying. And then here, the contracts are also annotated directly on the function. So let's take an example. If we scroll up, um, here's an example of contract. This is for another function here. So we have the requires clause, which is the precondition and the assumption of what function we're passing in, what can be passed into the function. And then we also have the ensures clause, which is the post-condition assertion that these conditions must hold true after executing the function. And let's come back to the harness itself. So in the harness here, we're just initializing the variables and then eventually calling the target function. And another thing to note here is any, for example, Kani APIs that we want to use, will all go in here, going in the verify module, and instead of going on top here, because we want to keep the Rust files as is and not touch it much. So for example, if I want to use the Kani pointer generator, that will help me to write harnesses, initialize non-deterministic pointers. I will just add it here. All right, now let's look at how do we actually run Kani, what command we need to use. So if you look at the bottom here, so right now the most convenient way is to run the run Kani sh script, shell script here. So let's take a look at what's happening with the script. So it's basically helping us install Kani to the correct version. So something to keep in mind here that for the Verify Rust SCD challenge, the Kani is constantly being updated, and there is always a special commit that's run for the CI/CD pipeline. So this script ensures that the Kani that's locally installed on your machine is the same commit. So that when you're trying to merge your PRs, you won't get any surprises or failures. And the other thing it does is that it runs the verification command for you. So let's take a look at what the command is here. So at the bottom, we can see the exact flags and options they've supplied. So first, important thing is to specify this option. Without this, there would be you will not be verifying the correct files. And then here, the -z are the unstable options. So they have supplied all the ones that are necessary to ensure no compile errors here. Something to keep in mind is that because Kani is quickly developing, sometimes they might release a new unstable features that's needed to avoid compile errors. However, it might not be included here. So if you see an error message, it could be that it's missing. So what we can do is either add it in the script and push it to let Kani team know, or the Verify SCD team know that you've modified it. Um, and the other thing is to see that here there's the output format, and you can change that as well. Other thing here to know is the object bits. So if you have an error saying that it's running out of object bits, you can come back to the script and change this number. And there are other flags that you can supply to it. So it does take in Kani arguments. So here, for example, what I want to do for the null is only verify this specific functions. So then I need to tell it which functions I'm verifying by using the -- harness flag. And so here there is a specific format to let you reach to the function and filter through to the one you want. So it starts with the pointer module, goes to null, and then you must also include this verify keyword. And then you can say, okay, now what's the function name that I want to look for? So here I just use check because this is the only one. Let's say all my naming conventions for this one is all null check dash the function name. Then if I want to verify all the harnesses in this specific module, then that's all I need to supply because you can think of it as like a regex matching. they will just match everything that matches the prefix, basically. And so I also output this to a verification log that I want to, so I can see the output. And then now with this, you can then run the command. And on the left side is what it will look like. So hopefully it all went green. And if there's an error here, it will also be outputted to the verification log, and you can check what's wrong. So hopefully by the end, it will show you that it has finished. And let's take a look at what the results look like. So with the output format of terse, it's pretty concise. And here we can see that it has run through 144 checks for this harness specifically. We can also see the name of the harness, the full name of the harness here, and then the time it took to run this specific harness, and the fact that there's no failures. So good news. So again, if you want to see what 144 checks exactly was applied, then you can change the output format, or you can remove that line so that it will actually give you the entire list. All right, I think that's all. I hope this video is helpful. And if you have any questions, feel free to reach out to the Kani or the AWS team. They're always active on GitHub, so you can file GitHub issues or post questions on the GitHub discussions. Thank you. I'll see you in the future.